and I'm going to share my screen. So, and for those who were here last week and I had trouble getting PyCharm to work, my PyCharm is now working. I had upgraded my Mac OS and it wasn't happy. So when I type examples, I will be typing them into a project in PyCharm. So as part of this, I'm also going to be reviewing how to use PyCharm. So when you need to use it for your projects and your assignments, you have a little bit better idea of how to use it. Last week we talked about just the introduction to Python, variables, and expressions. This week we're going to go a little bit deeper, and we're going to talk about the basics of strings, the basics of lists, and basics of dictionaries. Now this is just an overview because later on in this term we're going to do a deep dive into lists and dictionaries, but this is just kind of a way to introduce those ideas to you. We're going to talk about data types. We did a little bit of that last week. We're going to do more of it this week. We're going to talk about converting from one type to another. And then we're going to talk a lot about string formatting because string formatting is really important. Python pretty much assumes everything's a string unless you tell it differently. And it's really, really good at manipulating strings. So that's going to be the structure of the class. If you guys have any questions, just kind of raise your hand, and I will do my best to get to answer them. So what is a string? Well, a string is a series of characters. That's really what it is. And for Python, a string is anything in quotes. From the perspective of the language, a string is anything in quotes. So what do I mean by that? So I'm going to create a new project. I'm going to call it Module 2. Module 2. This window. For all of you, this is PyCharm. And ignore that. I'm going to create a new file, and where's my Python file? I'm going to call it strings. So what is a string in Python? Well, a Python, hold on, I want to make sure that, hold on. I think we're all right. A string is anything in quotes. So I'm going to create a variable. I'm going to call it, oh, no Python interpreter. That's what I thought it was going to say. They still don't know why that's happening. So I'm going to pick my Python interpreter. I'm going to apply, say OK. Now it's happy. So I'm going to say my stir equals, this is a string. So that's what we have as a string. And that's what Python recognizes as a string. If I can spell, G. And it's because it's in quotes. Now, what would happen if I removed those quotes? So if I remove the quotes, first of all, in PyCharm, I get these great red underlines. Let me make this bigger for you guys. So in PyCharm, if you have red underlines, there is something wrong. Also, if you have a red line over here, that's a line with something wrong. Now, the nice thing about PyCharm is that you can go and mouse over things, and it will give you more information. So what this is telling me is it has no idea what the end of the statement is. It doesn't know what this is. It doesn't know what A is, and it doesn't know what string is. That's because there's no quotes. The minute I add quotes around this string, all the redness goes away. Now I've got this orange string. It says no new line at end of line. Don't worry about that. It's not red. That's the important. So that's what a string is in Python. If you get red lines or if you're typing along and Python is giving you a hard time about things, it's because something might not be a string. And the other way to look at things is you can also just run it. So let me do that. Okay. I don't want to do that. I want to run it. Oh, I need to add a configuration. So Python, here's my configuration, and my script path. Sorry, I've got lots of weird. I'm going to put this down here. There we go. Say OK. So now if I attempt to run this, I am going to get this error. That's the other way you can know something is wrong. So there's a syntax error here, and it says invalid syntax. And that's another way of knowing that Python doesn't know what this is. So again, when I put quotes around it, I get this is a string. So I don't know how to stop those things from coming up. So does somebody not have their phone on mute? Yeah, somebody doesn't have their phone on mute. Thank you. So a string is a series of individual characters. So it's in fact a list of characters. And it's a special kind of list because there's only so many things you can do to a list. It's what they call an immutable list, which means you can't change it. You can copy it. You can make new lists from the list that look a little different, but you cannot change a string. Excuse me, I needed to take a drink. And each character in a string has a position. So the first character in a string has the position 0, and the second character in a string has position 1. And you'll notice that I said the first character in a string has position 0. This is very important. A lot of new programmers to Python think that collections or lists start at 1. They do not. They start at 0. If you try and start a list at 1 or look for the first character, things won't work right. So what do I mean? So I have my stir. So I'm going to say print my stir, and this is just the nomenclature and how you access a string or any element in a list. I'm just going to do the first 4. And I'm going to run it again. And you'll see that I get THIS. 0 is T, 1 is H, 2 is I, and 3 is S. And it goes on until you get to the last character of a string. That's just programming with strings. So let's see. So accessing individual characters, I just showed you that. So here's a challenge activity, reading multiple data types. So, oh, did I forget? Did I miss something? String concatenation. we did a little bit of this last week, but basically what you can do is you can, when you're trying to concatenate strings, and concatenate just means you're taking one string and you're butting it up against another string. So you're joining them together. But you can only join strings with strings. You can't join strings with integers. You can't join strings with floats. You can only join a string to a string. So you have to modify an integer or a float to being a string. And I think we did a little bit of that last time. But we're going to do some more this time. So this is the challenge. It says type 2 statements. The first reads user input into person name. The second reads user input into person age. Use the int function to convert the person age into an integer. Below is a simple output for the given program if the user's name basically is Amy and the age is 4. So we're going to do something similar. We're not going to do something exact. So I'm going to create a new file, Python file, and what am I going to call it? I'm going to call it, we're just going to call it challenge 2.1.1. Okay. So I have this, and I'm just putting this in here as a note of what we're going to do. And really what they want to know here is they want to know how to take an integer and add it to a string and add it to another integer. Whoops, sorry, I forgot my third quote there. So I'm going to just, I'm not going to do identical to this, so you'll still have a little work to do. But I'm going to say input, hold on, myStir equals input a string. And then I'm going to say my num, actually my int, equals input an int. And then I need to convert the person age into an integer and then add a number to it. So I'm going to, well, first of all, my int will not be a true integer. It will be a string. So I'm going to print myStir, and then I'm going to print my int. And I'm going to run these. Whoops. There we go. So I'm going to input a string, and I'm just going to say Lisa. And I'm going to input an int, and I'm going to input 29. And I get Lisa and 29 out. Now, 29 looks like an integer, but it's not. Because if I did my int plus 5, things might not happen the way I want. So I'm going to put Lisa, and I'm going to put 29, and then I get an error. This is a traceback error from Python. And what it's telling me is it says I can only concatenate stir, not int to stir. So I'm trying to add, and what's happening is my int is a string. Because whenever I bring information in from the console into Python, Python assumes it's a string. So what do we do? Well, what we do is we convert it using the int function, okay? Int says take whatever's in between the parentheses and change it into an integer. So now when I do this, I'm going to type in my name, I'm going to type in 29, and now I get Lisa 29 and 34 because I changed this to an integer. Now, on the converse, if I am trying to say print if I can type, my name is Meister, and my age is what's going to happen? Well, let's see. I'm going to type in, like I've been typing in before. My int is 29, and that new line has a problem. And now it's telling me error can only concatenate stir, not int to stir. And that is because I can't add strings and integers. I can add integers and integers, and I can add strings to strings. So in this case, I cannot treat my int as if it were an integer. I have to treat it as if it were a string. And when I do that, everything works fine. So that is what we're talking about when we're talking about strings and integers and types and concatenation. Everything has to be the same type to add it together, except for integers and floats, because they're both numeric types. So if anybody has any questions, let me know, or I'm going to keep going. So we talked about
I have a quick question.
Sure.
I was just wondering, with the quotes you put in between the program you just made, does it matter if you were like make a quote, space quote, and then put your plus sign? Because I noticed some programs have it like that. I was just had a quick question on that.
So let me make sure. So if I have another print statement, tell me if I'm wrong. I say print quote, my name is, and then do what?
Like how you have a space.
Mm-hmm.
Like, you know how some of them have spaces between the plus signs? I'm just wondering what what makes it have that? Like why it's needed.
Why this space is needed or this space is needed?
Do
you want to know if I can go like this?
No, it was more like when you're adding two things together, how sometimes you put plus sign, quote, plus sign, and then you put in what you're going to put, if that makes sense.
Plus sign, quote, like that?
Yeah, kind of, yeah. I guess I'm trying to figure out what I'm trying to say, I guess. I'll just let you continue and try to...
Figure out what you want. I'll be happy to answer the question. Or if you can give me an example, I'll be happy to answer the question as well, okay?
For sure.
Okay. So what is a list? Well, a list is just a collection of things. It can be a collection of characters, like a string. It can be a collection of movie titles. It can be a collection of integers. A list can be anything. There is a specific nomenclature to a list, and that is, I'm going to create another file now, Python file. So I'm just going to call it list, and I'm going to say my list. That, I just created a list. Okay? Now there's nothing in the list, but it is still a list in Python. So what is different here? Let me make this big again. These square brackets, that's what makes it a list. And ignore the squiggly lines under my comment. Charm isn't happy with them. This is what makes something a list. And they're very specific, and you have to have a left square bracket closed by a right square bracket. Now, and I can do things like print my list. Now, right now, it's not going to do much because I don't have anything in there. All it's going to do is print those brackets. But I can put things in my list. So I can put this as IT140. And I can put 2021. And I can put, you know, and I can put 1099, whatever that's for. And then when I print it, those things are there in the list. So a list contains different elements, different pieces of information. Each of these is a different piece of information that has some meaning, except for 1099. I don't know why I picked 1099. I have a string that says this is IT140. I have an integer that says it's 2021. I have the month of January, and I picked 1099 as a float. So I have a series of elements in one contained collection, and that is a list. And then there's all kinds of things you can do with a list. So let's keep going. And we'll keep going. And initialize the list, short names with Gus, Bob, and Zoe. Sample output of the program. Okay. So this is talking about, what this is talking about how to get at things in a list. So to get at things in a list, you use an index value. So in this list, there are 4 elements. There's 0, 1, 2, and 3. Again, it doesn't start at 1, it starts at 0. So if I wanted to print the elements in a list, I would print my list to 0, my list, and that's the way you read this. My list of 1, my list of 2, my list of 3. You can also say it, my list at index 0, my list at index 1, because that's what these are. These are index numbers. So if I run this again, I get this is IT140, 2021, January, and 1099, because I have used the name of my variable, because my list is a variable. That variable, I know it's a variable because it's on the left-hand side of a single equal sign, and I know it's a list because I have a left open square bracket and a right closed square bracket, and there are things in the middle separated by commas. That's a list. And I can get to each element in the list by using the name of the variable, an open left square bracket, the index number, and the right closed square bracket. Whoops, I didn't want to do that. Undo. Okay, so that's how you read this, and that's what a list is. It's just a way to have a collection of things. Now, why do I want a list? Well, I use lists a lot in my programming. I use lists, and I use maps, and I use dictionaries, I use all kinds of things, all kinds of collections. And that's because I want to keep like data grouped together when I'm in my program. Last week, we figured out how to put data into a program and add it to a variable. Well, now I want to expand on that, and I want to have data that is similar or has meaning kept together. And I can do that in a list. And as we go through, you will find that lists and dictionaries are going to become very important, especially in your project. So remember that when you're trying to figure out lists and dictionaries, because this is something you're going to have to learn as we move closer to when you're going to be turning in your project. There are all kinds of very cool functions that you get from Python. You can pop an element from a list, which removes it from the top of the list. You can remove it from the index. You can append a value. These are all just functions that you can add or remove things from a list, because unlike a string, a list is not immutable. A list is mutable, which means I can change it. I can change the order of it. I can remove things from it. So let me do a real quick example of that. So I have my list. So I'm going to say my list dot remove, and I'm going to say 3 because I don't know why I picked 1099. And then I'm going to print my list. And before that, I'm going to say print. Actually, what I'm going to do is I'm going to say print before remove. Actually, I think I don't need to do that. Yeah, that will handle it as a string. And then after remove. So let's see what happens. Let me run this. And I have a problem. This is my problem. I'm only allowed to concatenate a string. I forgot to do my conversion to a string, from a list to a string, and the interpreter corrected me. So now let me do it again. And let's see, what is it telling me? X is not a list. My list dot remove. Hold on, I gotta look at the syntax of it. My list dot append, my list dot remove. Oh, I thought it was the index, my bad. So here's what I did wrong. I used it as an index rather than the value. So I apologize. I program some days in Java and some days in Python, and occasionally when I come into this class, I get them a little mixed up. So what I did here, what you'll see is before remove has all 4 elements, and after remove I only have 3 elements. But let's say I didn't really want to remove 1099. Now I need to add it back. So I'm going to say my list dot append 2750. Don't know why I picked 2750, but I did. And so I'm going to say after append, we're going to run it again, and now I have 2750 in the list. You can see that down here. So those are functions you get. Now, what functions do I know? How do I know what functions I get? Well, that's where Google comes in. So where is it? There's a good one that's put out by Python. List functions. Here we go. This is a very, very good resource. And one of the reasons it's a good resource is that it's put out by Python itself. So if I'm looking for different things I can do in a list, this tells me everything I can do in a list. So docs.python.org We're on version 3, so it's 3 tutorials, data structures, because that's what this is. Lists are data structures and dictionaries are data structures. So if you're out on and you're curious or you're playing around with things and you want to see what you can do with a list, this is a really good way to see it, and also they always give you examples of what to do. So we're going to keep moving on. This talks about how you modify a list. Well, we just saw that we could append. The other thing that's important, that will become very important in the next couple of weeks, is the len function, L-E-N. L-E-N stands for length, and it tells you how long your list is. And that's important because soon we're going to do what we call iterating over a list. So it's important to know how many times you should iterate over a list. And because if you don't, you're going to get what they call an index out of bounds exception. But here are more methods and functions for lists. And they're very handy, and I suggest you play with them. So we're going to keep going. Tuples. I call it tuple, not tuple, but I don't care what you call it. A tuple is just immutable. That's all it is. And I don't use them that much. We won't really use them that much in this class. It's important to know that they exist, but frankly, if I'm going to use a collection, it's going to be a list or a dictionary. So let's keep going. We're not going to worry about name tuples. And then dictionaries. A dictionary is a different type of a list. Sorry, is a different type of a collection. The basic difference is you don't have indexes in a dictionary. You have key value pairs. And there's, again, a very specific nomenclature to it, very specific syntax, but dictionaries are amazingly agile and they are amazingly good at storing associative data. So what do I mean by associative data? Well, you have a key, that's a string, and a value, that could be a string, an integer, a float, or a Boolean. But you can marry those two up and be meaningful. So what do I mean about that? So I'm going to create another new Python file, and I'm going to call it dictionary. So a dictionary has very specific syntax. I'm going to say my dict is that. So let me make this a little bigger. Those are not square brackets. Those are curly brackets. And you know it's a dictionary because it opens and closes with curly brackets. So square brackets are a list and curly brackets are a dictionary. Now dictionaries have key value pairs. So I can say name comma age. We're just going to put 29 because we wish we were still that young. School. Oops, I don't want 29 to be a string. I want it to be a real age. And school is going to be SNHU. So if I look at this, what I have is on the left-hand side is a key. And on the right-hand side, there. You don't have to have those spaces. It's just easier to read. And I have my editor set up to tell me. So I have okay, yeah, that's just my editor being funny. It doesn't matter if you have no spaces one space, multiple spaces. So on the left-hand side, there's what we call a key. And a key is usually a string, and it has some meaning. And in this case, it has the meaning, we're giving it a name. We're saying the piece of information that's associated with this key is going to be a name. So the key is name, and the value is Lisa. The key is age, and the value is 29. The key is school, and the value is SNHU. So how do I get to elements in a dictionary? Because if I do this, let's see what happens. Whoops, running the wrong thing. Let's see what happens when I run the right thing. I get an error. It says key error 0. Well, that's because it knows that my dict is a dictionary. It's not a list, but I'm treating it like a list. So if this is happening, it's because you're treating your dictionary like a list. Now, the syntax is very similar when you want to get at something in a dictionary, but instead of giving it an index, you give it a key. So if I run it again, I get the word Lisa as output, and that's because I gave it the key of name, and the key of name associates with the value of Lisa. So if I want the age, I will do the same thing. And the key of age is associated with 29, and therefore it'll print 29. And the same with school. So that's what happens. That's the difference. So instead of this kind of invisible index for a list, you have a very visible key, and there's an association. The thing on the left-hand side of the colon is the key, and the thing on the right-hand side of the colon is the value. And these are called key-value pairs. So I'm going to keep on going. They're just talking a little bit more about dictionaries here. Now, you won't have to get into a lot of stuff about dictionaries, because we're going to be getting into a lot of stuff about dictionaries later on. So this is all lists. Do they have dictionaries in here? So tuples and sequences, sets, dictionaries. The same page has a whole lot on dictionaries, including lots of different examples. And you don't have to worry about looping techniques right now, but we are going to deal with looping techniques later on. This is just an introduction. And there are some ways to modify a dictionary and remove entries and add entries. They're similar to lists, but you use the key value pairs. So data types. I've already talked a little bit about data types, so I'm not going to kind of dwell on it very much, because I do want to review the labs. But there are two numeric types, integer and float. An integer doesn't have a decimal point, and a float does. You can add an integer to a float, you can divide them, they're both numeric types. You can do anything with them that you can normally do with a number. Let's see. And they're just telling you what the containers are here. A string, a list, a tuple, a set, and a dictionary are all container types. They're not integer or number types. So this is just an additional practice for grade calculation. So they're asking you to input 3 scores, and then you're adding those scores together. So that's all you're doing right there. And type conversions. We talked a little bit about this before, but it's important, so I'm going to go through it a little bit again. So basically, a type conversion is one kind to another. A string to an int to a string, an int to a float, a string to a float. You don't have to worry about converting an integer to a float or a float to an integer because they're both numeric types. And Python will do any kind of underlying conversion that you need for you. However, if it's not already a string and you want to add it to a print statement, it's going to have to be a string. Or there's some string formatters that we'll learn about later. But for right now, str is your friend. What do I mean by that? Well, let's go back to strings. So this is a string. I seem to like 29. If I do, this is an int plus my int, and I run this guy, run strings, I'm going to get an error. And I get my old friend that can only concatenate str, not int. That's because my int is an integer. So if I want to change it to a string, I'm going to use the str method. Okay? So the name of the function is str. It opens with a left parenthesis, it closes with a right parenthesis, and it has something in the middle. And in this case, it's my variable, my int. And so what I'm saying is, even though my int is a number, and I know it's a number because it's not in quotes, even though it's a number, for this one time only, I want you to treat it like it's a string so that I can print it out onto the console. So when I say str is your friend, that's what I mean. So let's keep going. Okay, string formatting. String formatting is really great, and it's actually quite easy. It's considerably easier in Python 3 than it was in Python 2. So, So what do we have? Well, we have the information that we want, and then we have our variables that we want to put there. But how do we get it there? Especially when you have long, like long strings or lots of variables. Well, there are these things called placeholders. And if we look here, these curly braces are a placeholder, and these curly braces are a placeholder. Now, what's the difference between the curly braces that I'm talking about now and the ones I just talked about for a dictionary? The difference is these curly braces are inside quotes, which are inside the print call to the print function. That's the difference. These curly braces are not dictionaries. If they are inside the print function, inside the quotes. So that's how they're not dictionaries. So I know it can be a bit confusing, but formatting is different than dictionaries. And so this is the specific time when you would use curly braces as something other than a dictionary. So I have the string inside the print function with my curly braces, and then I have a dot format. Well, the dot format just says, against this string that it's directly to my left, I want you to format it. And what I want you to do is I want you to put the value for the variable number into the place where the first curly brace is, and I want you to put the value for the variable amount into where the second curly brace is. That's all it is. It's direct one-to-one. Number gets dropped in here, and amount gets dropped in there, or the value for amount. So there are also ways to do positional replacement. So you can have three things in the format and then determine, like, there you want cat, and here you want hat, and there you want fat. But the important part to know is that this is very helpful and handy. It keeps you from having to put all those pluses in. So if I go back here, and let's see, And I've got all these pluses here. Well, I don't want all those pluses there. So what am I going to do? Well, I'm going to change this, and I'm going to print my name is and my age is dot format, and I'm going to say my stir my int. Now I'm going to comment this guy out. And then what we will see is, first of all, I've gotten rid of all those pluses because those pluses can be maddening. Secondly, it's easier to read, and I know what's going where. So I think personally that this way of doing your print statements is considerably easier than using the pluses. But so if I run challenge, I get, so I'm going to input my name, I'm going to input my wishful age, and it's going to say my name is Lisa and my age is 29 from this line. So that's easier to read, and that's why they have string formatting. It's just easier to do sometimes. So we're going to keep going. There's also what they call format specifiers. Now this becomes important when you're trying to do things like format, this is called fixed point notation. So if, for instance, you have a challenge or you have a project and you have to print, let's say 2 decimal places after a number, this is how you do it. So let me go back here and I'll show it to you just using this. Just going to make another copy. So I'm going to do that. So if I did 0.2F here, that's the only difference. Let's see what happens. Still Lisa, still 29. Whoops. My bad. So I'm going to say int, might have to be a float. Now what just happened was my int was a string, and you can't use that kind of format specifier on a string. So I'm having to turn it into an int so that I can run this. 29. Oh, sorry. Float. My bad. What is it telling me? My name is 0.2F. Float object has no attribute 0.2F. Yes, it does. Colon. Oh, my bad. My bad. Colon. I did not get the syntax right. Okay. My apologies for getting that syntax wrong. That little colon made all the difference. So the syntax is colon 0.2F. So in this case it says you're going to print it out with something after the decimal place. That's what F stands for. 0.2 means that I'm going to have 2 values after, 2 numbers after the decimal place. And the colon says we're about to do a special format specifier. And on my apologies, I forgot the colon. So that is what it's doing here. So that is why you get 29. So for example, if you had to print out an amount, like with a $sign in front of it, and you put a $sign there, if I put in Lisa and 29, I'm going to get $29. So if you have a challenge or something that does that, remember printing things out in this manner. Okie dokie. Let's see. Advanced string formatting. So we've already talked a little bit about that. This talks about field widths and fixed width, a way of taking it and making it look really, really neat. I'm not going to spend a lot of time on this. This is something that you will use for these challenges, but if you understand how the format goes, then you won't have too much trouble, and you're really not going to need a lot of that in this class. And frankly, I've never needed much of that since graphical user interfaces came about. So I'm really not, and we've only got a couple minutes, and I want to at least review the challenges. So I'm sorry, it's probably going to run past 10 o'clock or 10 o'clock Eastern Standard Time. So I've said a string is immutable, and it is, but you can break a string up and put it back together in a different way. They call it string slicing. And basically, you can tell a string, you can say my string should start at 0 and end at 3, set it to a different string, and that new string is now a subset of the other string. So in this case, when you look at string slicing, and here is the notation. So I have a string, URL. URL is a variable. It's on the left-hand side of a single equal sign. The value is this, is a URL for Wikipedia. And I want to know what the domain is. Well, there's a lot of ways I can do that, but one of the quickest ways is to say that from character 7 through 23, or actually from character 8 through character, from the 0 to 7. So it's, I'm sorry, I'm not being. From 7 to 23 will give me the domain, and then I can print the domain. So that would basically start here and go to there. That's the domain. So that's what I want to pull out. And the way I do that is to just say, okay, starting at this position, ending at this position, give me all the characters starting there and ending there and anything in between. And that's what it will do. And it's very quick and it's very easy and it's extremely powerful because it allows you to get things out of strings that it allows you to get information out of strings. Now you'll notice here that I'm not changing URL at all. I am setting the subset, the string subset, into another variable. And in this case, that variable is called domain. So domain will have this in it. It won't have any other parts of URL. It will just have that. So that's for string slicing. And this is more about string slicing. String methods. There are lots of string methods. There are a boatload of string methods. Find is good. Reverse find. Count is good. And again, if you go to Python and you want to look about strings, this is data structures. But I can also, there's modules, table of contents. This is the whole table of contents. New string methods to remove prefixes and suffixes. There are all kinds of things. So here's string. And this is everything for strings in Python 3. What it is, how it does. Oh, no, that's wrong. I selected the wrong one. That's new in Python 3.7. So sorry about that. But there are, string, the string module in Python. So this is what you get. And you can see there's just massive amounts of stuff on how to deal with strings in Python. We don't need to know all of them. And frankly, just to let you know, I don't know all of them. I never know all of them. I rely on being able to go out and look up the things that I don't know. I do not have an encyclopedic memory. Comparing strings, you can use the double equal sign. The double equal sign is not the same as the single equal sign. The double equal sign is called equivalent. It is not equals. So is the thing on the left hand side the same as the thing on the right hand side? And we'll deal a little bit more about those next week, and we'll deal a little bit more about Booleans and true and false, so I'm not going to spend a lot of time on it right now, because splitting and joining strings you can do as well. There are more string methods. The labs, name format. Sorry, I needed a drink of water. So we want to do a person's name here, and the output is going to be last name, first initial, middle initial. So basically what we're doing here is we're reversing some things, and we're getting the first character out of a string. So how do I do that? So let's just go here, and we're going to do something similar to that. So I'm going to do a new, file, new Python file. So what was it? 2.1. So I'm going to have last name, and then I'm going to have first name, and then I'm going to have middle name. Okay? And so what do I want in the end? Whoops, I have to have an N there. What do I want in the end? Well, for me, I'm going to have my output format. Now, this is not identical to the output format you're going to have, and there are some other requirements. But what I want the output to be is going to be last name, comma, first initial, and first initial, period. So this is similar, but it's not identical to the challenge you're doing. So what do I do? Well, first of all, I'm going to print something out. And what am I going to print out? Well, I'm going to print out the last name, comma, space, and then I'm going to print out the first initial, dot format. So what am I going to put in here? Well, I'm going to put last name, and now I'm going to put first name of 0. So let's see what happens when I run this. See if I got something wrong. Whoops, I'm running the wrong thing. See what happens when I run this. So my last name is going to be Shannon, and my first name is going to be Lisa, and my middle name is going to be Pam. And I get Shannon L. Oops, I forgot the period. So I want to do a period there. And if I run it again, I'm going to do Shannon, Lisa, Pam. And I've got Shannon, comma, L, period. So that is very similar to what you're going to be doing in Lab 2.1. So you're going to ask for 3 pieces of information in, and you're going to use your format specifiers here to print the name. So let's see if it tells us anything else. So last name, first name, period, middle initial, period. So we can probably add that on to what we were doing. And you got to make sure you have the spaces right. They're also saying if The input has first name, last name. The output is for last name, comma, first initial period, which we did. So basically, you have to make sure that if they don't input a middle name, that you can print out the right format, as opposed to if they do put in a middle name. So that's what Lab 2.12 is like. So now 2.13 is count the number of characters. So write a program whose input is a string which contains a character and a phrase and whose output indicates the number of items, number of times the character appears in the string. Okay, so this would basically be, let's see what string function we would want. Okay, I got to go back and look, because this is one of those times where I'm drawing a blank. So what we're going to do here is we're going to go to string methods and see what it tells us. Replace, find, returns the index of the first occurrence of item X. Find X star, count. Count returns the number of times X occurs in the string. So let's just play with count for a minute. So we're just going to do a new file. It's going to be 2.13. So Python file, lab 2.13. So let's play with count a bit. I'm not going to do the input. You guys know how to do the input at this point. But I'm going to say my_stir equals Mississippi. Well, I want to know how many times S shows up in Mississippi. My string. So I'm going to say, and let's say my care is S. So I'm going to say care is going to be my string dot count my care. And then I'm just going to print the number of in is that dot format my care my string number of care. So let's see what happens. So I've got a string that's Mississippi. Now when you do yours, you're probably going to have an input statement. I said the care is S, and again, you're probably going to have an input statement in your challenge. And then I'm now going to use the count function for string. I'm going to use it against the variable my_stir, and I wanted to count the number of my care, which in this case is S. So I'm going to run this, and it says the number of S in Mississippi is 4. Perfect. So now if I change this to P, the only change I'm making here is P. Whoops. And I'm going to run it again. The number of P in Mississippi is 2. So you'll see that what I have written here is very generic. I can change the value of my variables and get a different answer without changing anything else. And that's where we're going with programming. You come up with algorithms that are generic enough where they can work on different data. This is the start of that thought process. So this should help you get started on Lab 2.13. So does anybody have any questions? I'm quite happy to answer them at this point. I'm assuming that's no. And if that's no, that's just fine. I am going to stop the recording now, and I will be posting this probably tonight, maybe not till tomorrow morning, for people in my class. For people in the other classes, you can, your professors will be posting the information, I'm sure. And if you checked my YouTube channel last time, it's going to go up on the YouTube channel too. So have a good evening, everyone, and I hope this was helpful.